All right, everybody. Let's sort of continue our look at intervals here, and we're going to get into a really important topic here, which is inverting intervals. We started talking about this, but I want to go a little bit deeper because not only is it important, it'll help us on our homework, and from a practical side, or I don't even know, not practical, from sort of a musical side, it helps us to see the inner core of what an interval is and why they are the way they are. So let's not waste any time. Let's jump right into it here. And we are going to PowerPoint land for a second here, just to talk about this idea of inverting. So we sort of introduced the idea of inverting. And whenever we say that in music, we're really meaning that we're changing the vertical order or we're putting something different on the bottom. When we're inverting an interval, there's only two notes. So we're sort of flipping the top note to the bottom or the bottom note to the top. You know, there's not too much to do. So we can think about this as turning the interval upside down in a sense. What I was sort of mentioning a second ago is that I really think it's so cool when, and we'll see this in a second with these inversions, that by flipping the notes around, by flipping the interval around, we can see the true character and nature of each interval. And we can see the ways that these intervals are kind of interconnected with one another. You know, it sounds like we've got, you know, major, minor, perfect, augmented, diminished. It sounds like we've got these 5 different types of intervals, but really we're going to see that they're a little bit more woven together. So the first thing to talk about is that there is a little bit of a trick here with inversions, and this deals with the quantity of the interval, which is the number, right? So right now, we're not worried about the major, minor, augmented, that stuff. We're only worried about the quantity, the second, fourth, sixth, whatever. And the trick is that when we combine notes, when we think about both pairs of the inversion, their quantities are going to add up to 9 every time. We'll see this in a second, but keep that number in mind. 9 is the magic number for thinking through inversions of intervals in music. So I don't want to give too much away there. Let's get an example here, and we're going to keep that idea of adding up to 9 in mind. Let's look first at major and minor intervals when we invert them. So here's a bunch of some major and minors. So if we look C to E, we know that's a major third. We looked at this example kind of the other day, but if we do E to C, right? So now E's on the bottom and C's on top. We have inverted CE to EC. Same thing over here. We've got F to G. I could invert that by putting G on the bottom. So let's see what happens. Let's actually analyze what intervals we have here. We know that C to E is a major third, but what is it if we have E up to C, E natural to C natural? Well, number one, we know it's a sixth because E to C, 1, 2, 3, 4, 5, 6 letter names. So it's a sixth. And we know that it's a minor sixth because what kind of C would be a major sixth over E? It would be C sharp, right? Because in E major, we've got F sharp, C sharp, G sharp, D sharp. So C sharp is major, C natural is minor. And you can hear that, right? That darker sound. So what happened there? Major third inverts to minor sixth. Well, 6 plus 3, what does that equal? 6 plus, oh, it's 9, right? So we've got this 9 thing happening. The major, minor, we'll talk about that in a second. Let's look at the next pair. F to G is a major second, right? What kind of interval is this? G to F. Well, first of all, I'm not even going to count. Let's use the 9 trick. Let's do We could do it. We could do this either the subtraction way or the algebra way, right? So let's do the algebra way. We want to get to 9. 2 plus x, 2 plus what equals 9. The subtraction way would go 9 minus 2 equals 7, right? So we should expect that this would be some kind of seventh. And what do you know? 2, 3, 4, 5, 6, 7. G to F is a seventh. What kind of seventh is this? In G, what's the key signature of G? Well, G major's key signature has 1 sharp, and it's F sharp. So that means G to F sharp would be a major seventh. So G to F natural is a minor seventh, right? So we've got two things happening here. Number one, the intervals add to 9, right? 3 plus 6 is 9. 2 plus 7 is 9. But the even more interesting thing is that the quality of the interval switches. Major intervals invert to become minor intervals. Minor intervals can invert to become major intervals. So that's so cool that inside of this major third, in some way, is a minor interval. Inside of this minor seventh is a major second. So major and minor have this really strong relationship, right? They invert to one another. They're sort of connected, right? So again, with major and minor, the quality flips. So a major interval inverts to a minor interval, and the quantity adds up to 9. Always, okay? Let's look at perfect inversions. Do we think this is going to be the same? Do we think some of it's going to be the same? Let's find out. So here we go. We got D to A. D to A is a what? It's a perfect fifth. So what happens if we invert that? A to D is a fourth. 5 plus 4 equals 9. But what kind of fourth is it? Oh, it's a perfect fourth. Interesting. This is even clearer when you look at the octave and the unison, right? E to E, perfect unison. E to this E, perfect octave, right? So that it really makes it pretty stark there. But what's the thing that is really worth pointing out here? The quantity still adds up to 9, but the beauty of perfect intervals is that the quality stays perfect, right? That's part of what makes perfect intervals perfect. You can't flip this and make it not perfect, right? With major, we had that sort of great thing where, or I could do it this way. I think it's even better with minor. If I start with minor, right? See how dark that sounds? But I could do, see how bright? Right? I can flip that interval around and the quality will change. Perfect, not so much. Perfect stays perfect. That's what makes it a perfect interval. It is sort of set in stone. You can't move it around. Okay. Let's look at the last ones here. Augmented and diminished. So do we think augmented and diminished intervals are going to act more like perfect or more like major and minor? Let's see. So here we go. We got C to D sharp. C to D sharp is a kind of second. What kind of second is C to D sharp? Well, C natural to D natural would be a major second. So C to D sharp is an augmented second. So then if we invert it, D sharp to C, what's that going to be? D sharp to C. First of all, what's the quantity? We need to get to 9. 2 plus what equals 9? 7. So D to C is a seventh. Any D to any C is a seventh. D sharp to C is a seventh. And what kind of seventh is this? Well, do you think augmented is gonna and diminished are gonna flip, or are they gonna stay the same? Or do they have the underlying stability of perfect intervals, or do they have the changeability of major and minor? Well, of course, it's the changeability, right? So that an augmented second becomes a diminished seventh, right? That's super cool. One thing that I just want to point out really quickly, I'm not going to have it up on the screen here, but you can find these diminished sevenths because this is a really good example because D sharp, thankfully, isn't a real key. So another way to find these sevenths based on funky lower notes is to compare them to the octave. Just go down semitones. So D sharp to D sharp is an octave, right? Which means D sharp to C double sharp is a major seventh. D sharp to C sharp is a minor seventh. And D sharp to C natural is a diminished seventh. Just a little side note there that walking it down semitones from the octave can be a really useful way to find this. Okay, let's look at one more. B to F. B to F. It's an augmented fourth, and we know augmented fourths get a special name, right? So then let's invert that augmented fourth. We know that we just saw augmented flips to diminished. So this is going to be some kind of diminished, and it's a diminished what? B, C, D, E, F is 5. Oh, it's a diminished fifth. Huh, what's interesting about that? What's interesting about the augmented fourth becoming a diminished fifth? It's a tritone. They're both the tritone. B to F, or sorry, F to B, I mean, is the same number of half steps as B to F. Right, so I could go 1, 2, 3, 4, 5, 6. And then I could go 1, 2, 3, 4, 5, 6. Right? So the tritone inverts to itself, which is really cool. That's like one of those amazing sort of once in a generation kind of things, right? So augmented switches to diminished always, but with the tritone, with the augmented fourth, diminished fifth, it's even more cool because they invert to them, it inverts to itself, right? 4 plus 5 is 9, augmented flips to diminish, right? Really, really cool. So what I want to take there is a chance then to do a little bit of practicing. I want to take a chance to do a little practicing on something on our homework. So this is the last exercise on our homework, and I just want to go through how we do it because these are really tricky, but thankfully our idea of inverting can really help us. So this is the last one, and the instructions say something like, write the interval below the given note, right? So we've always written intervals above notes, but here we have to write the interval below the note. So if we start here, we can see already we're in for a fun time here because we've got an F and we need to write a major seventh below it, right? We need to write a major seventh below that note, which seems really daunting, but the trick is we can use inversions to really make this go very smoothly. So what's the inversion of a major seventh? Well, we know that we need to add to 9. So 7 plus what equals 9? 2. So it's going to be some kind of second, and the quality flips. Major becomes minor. So if I can make a minor second above F, if I can make a minor second above F, that means that I can easily just flip that around and make a major seventh below F. So how do I find a minor second above F? Well, what's a second above F? It's some kind of G. Very good. And I know that G, F to G natural, F natural to G natural, is a major second. So F to G what is a minor second? It's F to G flat, right? So F to G flat is a minor second up. So all I need to do is put a G flat below the first F, and that's a major seventh downwards. And I can check that by now thinking of G flat as the bottom note and using the key signature of G flat, which is 6 ungodly flats, right? B flat, E flat, A flat, D flat, G flat, and C flat. The only note that's not flat is F, and wouldn't you know it, F natural. So G flat to F natural is a major seventh. Did you see how we used inversion to easily find that? Okay, let's do it again. Let's do this one over here. Perfect fourth. Perfect fourth. I'm going to do the long way, quote unquote, long way first here. Let's use our inversion. So, what interval does a perfect fourth invert to? It inverts to a perfect fifth, right? Because we want the quantity to add to 9, 4 plus 5 equals 9, and perfect stays perfect. So if I can build a perfect fifth above E, that means that I can have a perfect fifth, right? So that was circular. So what's a perfect fifth above E? Well, it's B natural, right? So E to B natural is a perfect fifth because in E, we've got 4 sharps. B is not one of them. And so all we have to do then is put B below E, and that makes it a perfect fourth. What's the other trick you could have used here, though? You could know that perfect intervals with one pair of notes as an exception, with B and F as an exception, they will share the same accidental, natural to natural, right? So if this had been E sharp, it would be B sharp. If this had been E flat, it would have been B flat, but they're both natural. So that's a perfect fourth below. Let's do this one. Minor sixth. What does a minor sixth invert to? 6 plus what equals 9? 6 plus 3 equals 9. And major, just giving the answers away. What happens to minor? Minor flips to become major. So if we can find a major third above D, a major third above the note D, then we can have a minor sixth below D. So what's a major third above D? Well, what's the key signature of D? F sharp, C sharp. What kind of note is a third above D? Oh, F. So that means I need the kind of F I have in the key. I need F sharp because in D major, F is sharp. So that's D to F sharp is a major third, which means F sharp to D is a minor sixth. Do you see how we're ripping through these using inversion? If I know that D upwards to F sharp is a major third, then I can invert that. F sharp to D is a minor sixth. And we can check that. F sharp, again, not a great key, but it has 6 sharps. Father Charles goes down, remember that one, and ends. D sharp is in the key signature. So F sharp to D sharp, let me just sort of write that here. I could do it right in the middle here. So F sharp to D, how do I want to do this? I'll put it over here. F sharp, sorry, I can't stop saying F sharp. F sharp, let me do it this way. I'm going to change how these are spelled. 9. Oh, no, I had it. There we go. I just got to get down here. Boop-a-doo. So F sharp to D sharp is a major sixth because it's in the key signature, right? F sharp to D sharp. This is a major sixth, which means that F sharp to D natural is a minor sixth. See, you can always check. Okay, last one that we're going to do together. We need an augmented second. Oh, things are getting real now. We thought it was hard with major sevenths and minor sixths. Perfect fourth, that was an easy one. But augmented seconds below, goodness gracious. So now we've got to ask the question, is it always worthwhile to invert? Because if we were going to use that inversion method, what interval would we need to invert this to? We would need to make a diminished seventh, which for my money is a diminished seventh necessarily easier? Not necessarily. So what if we don't want to invert? And I'm going to say that the times where you don't necessarily want to invert are when the inversion creates a really distant interval. It might be easier to go just downwards, right? So let's think. Let's do this a different way. So what we could do is say, okay, here we are. We're on C sharp, and we know we need to go downwards by some kind of second. So first and foremost, we can just say, okay, here's C sharp. What kind of note is a second below C? Any kind of C. Well, it's some kind of B, right? So if I put B below C sharp, we can now just start to figure out where we are. And here's the trick. As soon as we have a bottom note, we automatically want to start using that bottom note to figure things out. So what we can say is, okay, I've now got B natural and C natural. So the question is, what kind of second is that? And then we'll go from there. So what kind of second is B natural to C sharp? Is it a major second, minor second? Is it already an augmented second? Well, we can think of the key signature of B. Father Charles goes down and 5 sharps. And you'll notice the second one, Father Charles, means that C sharp is in the key signature. So B natural to C sharp is a major second. Okay? So we've already got a major second, but we need to make it an augmented second. So what can we do? We know that augmented seconds are farther apart than major intervals. So we need this interval to get farther away. We need these two notes to be a larger distance. Now, the usual way we make things farther away is by moving the top note, right? If we've got a bottom note and we need them to be farther apart, let me just move the top note away, right? That's not what we need to do here, though, because we started with C sharp. So instead of moving the top note up to make things farther away, we need to move the bottom note downwards. If C sharp has to stay put, then we need to take B and make it farther away by moving it downwards. So if B natural to C sharp is a major second, what kind of B is going to end up being an augmented second below C sharp? What's a half step below B? It's B flat. Oops, I jumped a line. It's B flat, right? So that's a tricky one. But again, do you see how we can do it without inverting if the intervals are so crazy that maybe inverting wouldn't help us finding a diminished seventh? I don't know if that was necessarily easier. Anyway, those are the answers for the first 4. So if you watched this video, you just got 4 free answers, which is nice. And I hope that clears up how we can use inversion to not only define and find the character of these intervals, but also to sort of make difficult processes, maybe when we have to find intervals below, a little easier. All right, thanks everybody.